All right, let's take a look at our lesson for today. We are going to be looking at the derivative. Yay. Average rate of change, we actually talked about this. I want to say it was our very first lesson this year when we talked about average rate of change, and you would have probably talked about that last year. It's really slope of the secant line, average rate of change. It's a formula that we need to know. It's basically just finding the slope of a line if you want to, just basics. That's what it's doing. It's the change in y over the change in x. So that's a formula that allows us to calculate the average rate of change. Notice that the average rate of change is being calculated off of a position. Oh, I don't know. You have to look on the syllabus. I can't keep track. I just can't. There's too many different schedules. Okay, so that's our average rate of change. Now let's take a look at instantaneous rate of change. This finds the slope of the tangent line for us. It's also known as the derivative. We have two formulas. This first formula, the first one, will find us an equation. Okay, so the first formula will find the equation of the derivative. That's what it finds. It's pretty important to understand and be able to use it. Later on, we will learn rules to find the derivative, but right now we're going to be practicing using definition of the derivative. We also have another formula. This is called the alternative form of the definition of the derivative, and when I put this on a formula quiz, what I would say is, for this one, I would say definition of the derivative, and you're going to put, this first one, all right? If I say alternative form of definition of the derivative, you would put this one, okay? They have slightly different names. And for the alternative form, what this finds for us is it finds the slope of one tangent line. It doesn't give us an equation. It gives us a number. So this formula will generate a number for us, and this formula will generate an equation for us. So if they don't tell us which one to use, we would choose the one that we use depending on what we wanted to find. If we wanted to find the equation, we would use the one in green. If we just needed one number, like the slope of a tangent line, we would use the one in yellow. And for the formula for the tangent line, it's actually my favorite. This is point slope form, if you remember that from way long time ago, right? Algebra 1, you learned point slope form of a line. That's all this is point slope form of a line. We've got so y minus y1 equals m times x minus x1. Isn't that lovely? It just decides, I don't want to write anymore. Luckily, I have a spare pen. All right, so this is, hopefully you can look at these and see they're basically the same formulas. This f prime of a is the slope, right? That's what that is. And then a is the x value, and f of a is the y value. Those are the same formulas. On the formula quiz, if I ask you for the tangent line, you could give me either one of those. You could give me just point slope. I'd be okay with that. Or you can give me the more formal y minus f of a equals f prime of a times x minus a. Either of those is fine. Notation, when we are finding a derivative, they like different notations. Now, we have, two fathers of calculus, Newton and Leibniz, and, I don't really remember which one did which, but one of them made this kind of notation, and the other made this kind of notation. It doesn't really matter which one you use. There's different uses. A lot of students actually prefer the f prime because it's a little faster to write. That little dash right there is called prime, f prime. I'm just going to say we had that word before Amazon. Okay, prime, f prime. And then we've got dy dx. This has a specific meaning this means the derivative of y with respect to, W period R period T is an abbreviation for with respect to x. And so this last form right here actually gives us more information than the others, but it means the exact same thing. There's no difference between, choosing which one to use. You can choose whichever one you want. All right, so I'm going to pause here for a second. Are we okay on our new formulas? Just the overview of formulas. We're going to practice this, but I just want to make sure we're okay on the formulas.
On the formula quiz,
yes, ma'am.
Give you either F prime or the Q over TF?
Yes, you can choose which one you want. Yes, ma'am.
What is the formula quiz going to go up to? What are the new formulas?
All right, so now let's take a look at a visual picture of what we're talking about up here. So slope of the secant line, this f of b minus f of a, what they're doing is they're actually calculating the slope of that line. That's what that formula does. The f of b minus f of a over b minus a, this slope of the secant line formula, that's what this calculates that slope. Okay? This green formula, this tangent line right here, it calculates the equation. What this does is it calculates the equation that we would use to find slope of tangent line. So that's what that equation would do. It would give us the equation that we would use to find the slope of the tangent line. This yellow equation would just give us the number, just the slope of the tangent line. That's what it would give us. Okay, now let's talk about the normal line. The normal line, we really don't use the normal line very much in AB calculus. The normal line is used quite a bit in multivariable calculus. So we're just going to talk about it. So this normal line is used a lot in multivariable calculus. In AB calculus, we just need to know how to find it. That's all. So what is the normal line? The normal line is the line, okay, it's the line that is perpendicular. Remember that little notation from geometry, that little perpendicular? This is the line that's perpendicular to the tangent line at the point of tangency. So that's what a normal line is. It's the line that's perpendicular to the tangent line at the point of tangency. You see right here in this diagram, we've got our tangent line right here. And then we've got our normal line, which you can see the little box thingy that shows perpendicular. It's perpendicular to the tangent line right at the point of tangency. That's my point of tangency, which I just highlighted right there. You probably remember from, Algebra 1 or previous, that if you multiply two slopes together and get a -1, remember that means that they're perpendicular to each other. Remember the relationship? So if my tangent slope, if my tangent slope is, say, 1/2, if my tangent slope is 1/2, then the normal line slope would be what? Do you remember? It would switch signs. It would be -2, exactly. It would switch signs and it would do the reciprocal. So that's just the relationship. And if I multiply 1/2 times -2, I get this one business. That's what it was talking about.
Wait, so opposite sign and then reciprocal?
Yes, opposite sign and the reciprocal. So they're opposite reciprocal for our normal slope. Okay, so that's the background of the things we're doing today. Okay. So let's take a look at some of the questions. This one is similar to it is actually one from AP Classroom. I don't think this is one that we gave you, but would be similar to some that were on there. So let's read through it, try to figure out what to do. We really need to focus on the words. If you don't know what to do, dig into the words. Selected values of a function g are shown in the table above. Okay, we see some random values. Great. What is the average rate of change of g over the interval? This word right here, average rate of change, should make you think of a formula. It should make you think of a formula when you see that word. So average rate of change, that's f of b minus f of a over b minus a. That's what that word should, the phrase should kind of trigger. That's a formula. Okay, great. Well, we can do that. In this case, the function's name is g. That's fine. So let's see. We're looking at 2. Let's just kind of highlight. We're looking at 2 and negative 2. These are the data points that we are interested in. So this one would be, B, and this one would be A, because they're in order, right? A is the one on the left side of my, the smaller number, and B is the one that's bigger. So f of b would be 5 minus f of a would be negative 3. Okay, so we take the difference of our y's. Then our x's is going to be 2 minus a minus 2. And then we just go through and look to see which one of those answer choices would work. And we see that it is B, would be our correct answer. All right, any questions on that problem? Okay. On the next problem, we're going to find the equation of the tangent line to the graph. All right, so another vocabulary word. This vocabulary word, equation of tangent line, should make you think of the formula. Make you think of the formula. The formula was y minus, and we can say f of a equals f prime of a times x minus a. And if you don't like that formula, you could just say y minus y1 equals m times x minus x1. Either one of those formulas is perfectly fine with me, whatever sticks in your brain better. Okay, so what do we need? What do we need? We need 3 numbers. Okay, we need to find 3 numbers. We need to find this number. We need to find this number. And we need to find this number. Those are the 3 numbers we need to find. Okay, we're actually given one of the numbers right here, 2. 2 is going to go right there. That's my x value. Okay, great. Is it possible for me to find my y value right now? I can, can't I? Can't I just plug 2 into the equation? Wouldn't that be okay? So f of 2 would be 3 over 2. Okay, great. And that number is going to go here. Okay, yay. So I have 2 of the 3 numbers. That's wonderful. The slope is the one who is going to be a little bit harder to find, because where does the slope come from? It comes from the first derivative. The slope comes from the first derivative. We do not have the first derivative. That means we need to find it. So let's make ourselves a note. Okay, so for slope, how are we going to slope is a value of the derivative. Specifically for this problem, it's the value of the derivative at x equals 2. That's what we want. We want the value of the derivative at x equals 2. So let's look at our 2 formulas up here and figure out which one we want to use. We get to pick. Okay? So the green formula will give us the equation which we could plug a 2 into. That's fine. The yellow one will go straight to the answer, straight to the slope at 2. I think I want to use the yellow one. It will be faster. It would be faster if we can just go to, we just need one number. We don't need the whole equation. So why don't we use the yellow one? We're going to use the alternative form so we can just get our answer. All right, so let's set that up. So we've got the slope, which is the same thing in this case as f prime of 2. That's the one we want. We want the derivative, first derivative at 2. Our formula is the limit as x goes to our number, which is 2, of f of x, which is 3 over x. So let me write the formula up here since we don't have it memorized yet. So the limit as x goes to, are they using c's? Yeah, they're using c's. As x goes to c of f of x minus f of c over x minus c. That's my alternative form. All right, so in this case, c is 2 because we're wanting to find the derivative at 2. C is 2. So limit as x goes to 2 of f of x, which is 3 over x, minus f of c. So I need to plug in the 2. So that would be 3 over 2 over x minus 2. Okay, so when we finish working this limit, we should get our answer for f prime of 2 and be able to finish the tangent line. Now, we've been working limits for a while now, and if I plug a 2 in there, I get 0 over 0. When I'm doing limits and I get 0 over 0, what does that mean? Keep going. I got to keep going. There's four main things to do, pretty much only 4 things to do. Number 1, we could factor. Is that going to help us? Not really. Number 2, we can multiply by the conjugate. I don't think that's going to help us. We could try it, but number 3, we could get a common denominator and add fractions together. That's where we should head. When we have a complex fraction, we should do that third type. Get a common denominator, add together. So let's do that. We need to work in the numerator. So in the numerator, I'm going to multiply the first fraction by 2 over 2 and the second one by x over x. Why? Because my common denominator is 2x. 2x. Okay, so here we go. So we've got the limit as x goes to 2 of 6 over 2x minus 3x over 2x all over x minus 2. Okay, so I got a common denominator, and now I'm going to add them together. Okay, so let's just do an arrow just to show which way we're going. Please don't do equals. Limit as x goes to 2 of, let's see, we have 6 minus 3x over 2x all over. Please be sure to make your main fraction bar bigger so you don't get confused. So when we have a complex fraction, do you remember the whole keep, change, flip? That's what we need to do. We need to keep the top, change division and multiplication, flip the bottom. Keep, change, flip. So let's do that. So the limit as x goes to 2, keep the top, 6 minus 3x over 2x. Change division and multiplication, flip the bottom upside down. You know, basically this is over 1. Okay, wonderful. If I put a 2 in there right now, I still get 0 over 0. So there's something else I need to do. Look what we have. Any ideas on what I should do? Absolutely. I need to factor. I really need to focus on this right here. And if I factor out a negative 2, no, excuse me, a negative 3, won't that help me? Won't that turn that around for me? Let's try it. Okay, so we've got the limit. Let's put a little arrow. The limit as x goes to 2. I'm going to factor out actually a 3. I'm going to factor out a negative 3. Factor out a negative 3. That leaves me x. I'm switching the order of it so that it matches what I'm doing. Minus 2 over 2x times x minus 2. So I'm going to pause here for a minute, make sure we're okay. If you're concerned about the factoring, all you have to do is just multiply it back out and make sure you got what you started. So negative 3 times x is negative 3x. Negative 3 times negative 2 is 6. So we're back where we started. Now what can I do? Cross out, right? Can't I cross this out? Okay, perfect. Now I plug my number in, and I get that f prime of 2. So I put a 2 in there. I get negative 3 over 2 times 2, which is negative 3/4. Okay, now I have everything that I need to write my tangent line. So let's look and see what we had. So we've got y minus 3/2. We had already found the 3/2 equals, my slope is negative 3/4 times x minus 2. Please, please do not distribute and combine like terms. Leave it alone. Leave it in point slope form. It will be much easier for you if you leave it in point slope form. If you really can't handle it and have to multiply and combine like terms, you're taking a chance, because if you make even one little error like multiply wrong or add wrong, you lose the point. So please just leave it like it is. Now, that's the first time that we've actually used the definition of the derivative. Students find it challenging. If you're finding it challenging, that's okay. That's normal. Later, we will learn other ways to find derivatives, but right now we're focusing on definition of the derivative. Okay? It just also further helps us with our limits. All right, so let's go to the second page. We've got 2 more examples to do. So number 3 says the following figure shows the graph of f and a line tangent to the graph of f at 6, at x equals 6. Find f of 6 and f prime of 6. This is really just kind of figuring, determining whether we really know what that means. What does it mean? What does f of 6 mean? What are they asking us to find? The point, right? They're asking us to find the y value. Right, f of 6, this is the y value of the point. That's the y value of the point, and that's what they want us to find. So we go to the graph and we look at 6, and we see that this is our point. So f of 6 is 5. Not too bad. F prime of 6. We need to interpret, what does that mean? What does it mean when they ask us to find f prime of 6? What does that, how does we read that on a graph? It's the slope. It's the slope of the tangent line. So I just really need to count my slope or figure out how to get the slope. Since the graph is pretty clear, I can count it. If it's not, I could find 2 points and do, the slope formula. So it looks pretty clear. Let's see. So we'll just start right here. If I rise 2 and I run 1, that seems pretty straightforward. So that's up 2 and over, it's going left. So our slope is negative 2, which means f prime of 6 is negative 2. So what this question is trying to do is to determine if you know what those things are. And if you know what they are, then how do you find them? Okay, is everybody okay? All right, we have one more question. This is actually a free response. You're going to have one very similar to it in your AP Classroom. That's why we're doing one in the notes, because you're going to have one that looks like this. So let's kind of walk through it so that you'll be able to do your AP Classroom work on this. All right, so let's see what we have. The graph of the function f and a table of selected values of f are shown. Here we go. We've got our graph right here, and we've got our table. That's our focus of our problem. The graph f has a horizontal tangent line at 2. Okay, so I like that ruler. Do y'all like that ruler? It makes me happy. I know I'm a weirdo. It's okay. So I've got a horizontal tangent line at 2. I'm just going to draw that just so it kind of stands out for me. Let's see, it's concave up from 0 to 5. So concavity, are we familiar with that word? Do we need to go through that definition? Concave up, concave down. Concave up is like it's like up, cupped up. Like this is concave up. That's concave up. This is concave down. It's like if you had a cup of water and it was concave up, that would make me happy. If I had a cup of water and it was concave down, that would not make me happy because it would all spill out. So concave up, concave down. That's what those words mean. And you can see from the graph, what they're saying is accurate. From 0 to 5, it is concave up. And it's linear when x is bigger than 5. Okay, that's great. Good information. I highly encourage you to read through the information and make sure you understand each thing that it says. Don't just gloss over it. If you gloss over it, that's generally where we get in trouble. All right, we want to approximate the value of f prime of 4.5 using the data from the table. They are telling us, use the data in the table. That's what they want us to do. Show the computations that lead to your answer. Now, I will tell you, this one is especially tricky. They're being a little rude to us. Imagine that. What we would normally do is so here's 4.5. To approximate the derivative, we would usually go on either side and use those numbers. Let me tell you why we can't do that, why they're not being very nice. What's happening between 4.5 and 5? A jump. That's why we can't use 5. We can't use 5. They just rip that out from underneath us. So instead of using 5, how we would prefer, but since there's a discontinuity there, we can't use it. We're going to have to actually, which we don't normally do, we're going to have to actually bring it back in tighter, and we're going to have to use 4 and 4.5. You should make a note to yourself on why we can't do this. So, and I will make a note also. So let's just make a note. It says we can't use 5, cannot use x equals 5 because of the jump discontinuity. Really, any discontinuity would ruin it for us. But in this case, it's the jump. So can't use it. Actually, yeah, discontinuity at 5 would make us not use 5. All right, so let's do our approximation. We're going to do our approximation. We're going to let's make ourselves a note. We're going to approximate the derivative using slope of the secant, which is f of b minus f of a over b minus a. That's what we're doing. That's a legitimate way to approximate the derivative when we have no other choice. This is like our last choice. Okay. So let's do our work. And this is non-calculator, so yay. So f prime of 4.5, is approximately, okay, so we're going to have to use these right here. This is the numbers we're using right in here. Okay, so it's approximately 193 minus 2.533 all over 4.5 minus 4. Now, since this is non-calculator, we can just subtract the two top numbers, which I did, and I get 0.660. And we can subtract the two bottom numbers, which, I did. I get 0.5. And if you don't want to go further than that, I'm okay with that. I'm okay. You can just leave it right there. If you want to go further than that, you can. But you don't have to, because we don't have a calculator, right? And this, they say we can't use a calculator. We don't have a choice. All right, questions on part A? Yes, ma'am.
Did you just take like random
No, because since we want 4.5, we have to get as close to it as possible.
Oh, so it's like the same thing. We could just add like the different ones.
Yes. Yeah, if they wanted, right, to say if they wanted us to approximate f prime of 3.2, which numbers would we use?
3.5.
Exactly.
Oh, okay. So you can, if the number that you're approximating is like is one of the numbers actually, and it's not like in between something, you can use one before or after.
We typically use the one before and after it. That's why this one was very troubling, very rude to us, because we weren't allowed to use the 5. That's what we would normally do. We would use the one before and the one after to get a good approximation. But since 5, there's a discontinuity there, we had to scrap our main, plan and go to plan B, where we use the actual number. That's not normally what we would do.
Oh, okay.
Does that make sense? Okay. Is everybody okay on A? All right, let's look at B. Is there a value of x for 0 to 5 such that the limit as h goes to 0 of f of x plus h minus f of x over h equals 0? Okay, first we need to interpret what is this? What is this? We need to figure out what formula they're giving us, or we're not going to even know what to do. So that looks like a formula we just talked about, right? What did that formula give us? That was the green one, right? That gave us the derivative. That gave us f prime of x. So what they're saying, so let's just write that out. So the limit, and they want us to write it out. I'm telling you, they want to see this work. The limit as h goes to 0 of f of x plus h minus f of x over h equals f prime of x. That's what that formula gives us. So what are they really asking us? They're really asking us, is there a place between 0 and 5 on the graph where f prime of x is equal to 0? Is there a place? That's what we're looking for. And f prime of x is the slope of the tangent line, right? Slope of the tangent line. Is there a tangent line between an x of 0 and an x of 5 where the slope is 0? It's a horizontal tangent line. Yeah, didn't they specifically call it out for us? Right? The one that I drew, I was really excited to use a ruler. That one? So, yes, there is a place. So let's go through what we would say. So this is what we're asking. And what we would say, yes, the tangent line at x equals 2 has a horizontal slope. Well, that's wrong. The tangent line at x equals 2 is horizontal. The tangent line at x equals 2 is horizontal. Therefore, has a slope of 0. So f prime of 2 is 0. And let's make sure we've answered the question, is there a value of x 0 to 5 such that? Okay, so what we have to do is we have to go back to the prompt and make sure we've written everything. So f prime of 2 equals 0. So the limit as h goes to 0 of f of x plus h minus f of x over h equals 0 at x equals 2. We're copying what they asked. They asked for this, and we're making them happy by copying that prompt into our answer. We need to put the prompt in the answer because that's what they asked. Okay, how we doing? Okay, last problem. And now this one's weird. I'm not going to lie. It's just weird. You're like, that other stuff wasn't weird? Okay, this is weirder. Okay, so it wants to know for each of the following limits, find the value or explain why it does not exist. Okay, so what I would like to do is start with the most obvious part of it, the most obvious. This one is the most obvious. What does this find? Let's think about, so let me write out our formula. So our limit, the definition of derivative, limit as h goes to 0 of f of x plus h minus f of x over h. I want you to compare these two and tell me what they did. What did they do to the one I circled from the formula? What did they do? They put a 5 in for x. This formula gives me this one, tells me f prime of x. So what do you think this one is going to tell me? F prime of 5. Exactly. This is telling me f prime of 5. That's what it's telling me. So how do I know? I compared it to the formula that I've memorized. I look at it and say, what's different? What's going on here? This is how our problem solving strategies. What's happening? Okay, well, look, they took the x out and they put a 5. What does that mean? Well, since this gives me f prime of x, that means this one's going to give me f prime of 5. Does everybody understand? All right, so now let's look at the graph. Does the derivative exist at 5? No. Remember the three reasons we'd be non-differentiable? Nope, we haven't talked about that. We can't be differentiable at when there's nothing there, when there's a discontinuity. It's not there, we can't. So this is supposed to equal, so let's finish 3 out because this is the most straightforward one. This is supposed to equal f prime of 5, which does not exist because a jump discontinuity, and any discontinuity would ruin this. It doesn't have to be a jump. Any discontinuity would ruin it. So because of jump discontinuity, therefore it's not differentiable. Not differentiable. Okay, that one is pretty straightforward. It's the one-sided limits that are just super weird. Okay, so let's go to the less weird one. Part I is less weird. So let's focus as we're coming from the right. So we're coming from the right, and what's happening is this formula is finding, it's a one-sided derivative. This one is the right-sided derivative. That's what it's calculating, the right-sided derivative. Is it possible to find the slope coming from this way? Yeah, it's just a line there, right? Can't we do slope? So it's up 1 over 1, 2, 3, 4. So m equals 1/4. Now the significance here is we're coming in as a line, and this is solid. We're continuous all the way to the end. From the right, we're continuous all the way to the end. So therefore, the answer to this limit equals 1/4. It's 1/4. Okay, we're continuous to the end. Our slope is 1/4. Coming from the left is the weird one. So stay with me. This is weird. I'll go through the explanation here. As I'm coming from the left, what's happening is I'm approaching here, and I am not equal right here. I'm not left continuous. This is not left continuous. So my derivative from the left doesn't exist. I'm not left continuous. So this derivative from the left does not exist. And the technical reason that they're giving, because, and I'll walk you through why, because I would actually be okay if you say because it's not left continuous. I think that, let's just go with that, not left continuous. And what do I mean by that? That means that the function value, it doesn't go to, we're not headed to a point, we're headed to a hole. It's not left continuous. So we're just going to go with that. Okay? All right.